So we have coming up shortly 3 papers presented. We have 60 minutes for this session, so I'm expecting the papers to be presented in roughly 15. That'll leave us maybe 15 minutes at the end for some Q&A. So for those of you who didn't notice yesterday, the way this is going to work is we're going to ask the presentation to be given without interruption for Q&A. And without a Q&A portion right at the end of the session, at the end of the paper. So we'll see all 3 presentations. At the end, we'll have a discussion session. So we'll ask you to type into the chat, so we have a record of it, type your questions for each of the authors as we go. So if you have an author for Chin-Ru, the first paper presentation, just type it into the chat and then we'll discuss that at the end of the session. All right, so we have 3 coming up. The topic is multi-domain architectures. The first presentation is coming to us from Beijing. So welcome Chin-Ru Wang and co-authors. Are you ready for your presentation?
Yes.
Wonderful, welcome and thank you for joining us so late at night. You can share your screen and start your presentation.
This is a project clustering and the risk monitoring based on QFD and MDM. I'm Chin-Ru Wang. First is introduction. From the perspective of project management, risk can be understood as a potential threat to the project once it occurs, and it can also help be understood as the author factor that may have an impact on the entire process of the project. Large and medium-sized engineering projects generally have large investments and long periods. In the process of construction and production, they are often affected and interfered by many factors. There are main reasons for the complexity of the project. First, the dynamic nature of the project, that is due to project in the project cycle and the project status. The dynamic change of the project in different cycles is transient. The second is model building. As shown in Figure 1, to establish a risk event and a risk QFD, risk factor QFD. First, the product design expert determines the weight of each event demand and determines all the key risk factors related to this event. We can see the QFD and the event DSM. After determining the weight and the relationship metrics of each risk event, the relevant importance value of each risk factor can be obtained from Formula 1. In the formula, we can calculate the weight and relationship metrics. In the R&D project management, control dependencies are the key considerations of project management. Project managers need to weigh the impact of changes in key risk factors on different risk events. Therefore, this article do not consider the impact of non-restricted dependence on the project and only consider this to restrict the dependency relationship. The dependency strength WDSM between risk events A and M in the risk event DSM can be calculated by Formula 2. As shown in the Figure 2, the diagonal position in the risk event project MDM represents the risk event DSM and the project DSM, and the off-diagonal position represents DMM. A basic MDM analysis of the inter-domain dependencies between elements is established. If the dependency between the risk event and the dependency between the risk event and the project is sure. The strength of the dependency relationship between can be shown in the Formula 3. Project DSM is the static DSM model, and the clustering method is usually used to optimize it. Clustering method can be divided complex project into several different categories or modules. Usually, each module is composed of projects with high risk correlation, make the degree of dependency with the class closer, and reduce the degree of dependency between classes, achieving the goal of reducing management complexity. As shown in Figure 3, usually the goal of DSM clustering is to reduce the dependence of the external class or increase the dependence of the internal class or by changing the position of the element in the DSM. That is, through the clustering operation, it has a strong interaction. Most of the elements of DSM cluster into the same category, and the interaction strength dependency between the elements outside the category should be as weak as possible. According to different application fields, the existing DSM clustering objects include minimum description length, minimum description length, maximum module measurement, or minimize coordination costs. We can see in this picture increase the dependency on sending information within this cluster. The ratio of the to the number of newly added of this category ADS can be calculated by this formula. The interaction strength between the project and other projects is calculated by question 5. That is the dependence strength between the projects, which facilitates the grouping of the project with strong correlation, so as to achieve better monitoring and management of the project set with high risk correlation. This is the conclusion and the future work. Current projects have faced with various risks. How to grow projects with high risk correlations together to facilitate management has become a hot topic today. Therefore, this article first constructs the dependency matrix between risk events and risk factors, and use the QFD methods to derive the risk event DSM matrix and obtains the dependency relationship model between risk events, then constructs the risk dependency relationship between the project through risk. The event project MDM drives the project DSM. Finally, the project DSM is optimized and analyzed by the clustering method, and the dependency intensity between the project is calculated, which is convenient for monitoring and managing the project site with high risk correlation. In the future, it is mainly through big data methods to collect the risk events and the risk factor to facilitate cluster management of projects with a high degree of risk correlation. In addition, you can continue to optimize the clustering to facilitate monitoring and management when there are many items. Thank you. It's my presentation.
Thank you, Jinru. I know it's very late at night for you. I hope you'll be able to stay for another hour and take the questions. I see 2 or 3 questions already in the chat for you. So you may take a look at those. now, but we'll come back to you with questions. Will you be able to stay awake and join us for another hour? Chinru, I hope you'll join us.
Okay.
Okay, so you'll be able to join us to answer questions. We're doing those at the end of the session. So we have 2 presentations coming up first. All right, our second presentation is from MIT. I'm one of the co-authors, but my co-author is Professor Nitin Joglekar from Boston University, and our now graduated master's student, Nitin Narayanan, have both joined us. Nitin Narayanan is going to make the presentation. He's actually now at Amazon. And thank you, Nitin, for joining us. The floor is yours for your presentation.
Sure. Thank you so much, Steve. So, hi all. I am Nitin. I hope you can hear me.
Yeah, we can hear you. Go right ahead.
I'm currently a senior product manager at AWS over at Amazon. And I'm an MIT alum, as Steve mentioned. And during my grad studies, I had the opportunity to work under the advisement and guidance of Professor Eppinger and Professor Joglekar in exploring the application of DSM in scaled Agile, which is for large software development programs. And this presentation is one of the outcomes that we saw while researching in partnership with Swisscom, which is a large telecom-based service provider out of Switzerland. So before we get into the thick of things, I just wanted to talk a bit about scaled Agile. So it's becoming an increasingly common practice for large enterprises to adopt scaled Agile, especially because of its the agility and ability to go into market at a faster pace, as opposed to a traditional waterfall method, which is very slow to react to the business needs. And scaled Agile consists of several layers in the organizations, if you will, where the information flows up and down. It always starts at the organization level, where you have the enterprise architects and owners of the large solutions who work together in defining the vision and mission of the organization and how a program should evolve, which translates into high-level requirements, such as large capabilities. For instance, if you're building a new website for a new organization which requires a website, you start by defining what that website would require. And the large capability will define various high-level features of the website, such as, okay, we need billing, we need customers to have the ability to search for our products, and we have to have product listings, which further breaks down into what those particular services are and how that can be converted into technical features, which individual teams of developers and members can work on to deliver that to meet the vision of the larger organization. So as you can see here, the information flow predominantly, when it comes from top to down, it looks at the high-level requirements, the priorities, what needs to be delivered ahead of what in order to reach our customers, and the value that each of those higher priority requirements have, and the schedule. When do we plan to get this out to our customers, or deploy this, or deliver this value? And from bottom up, when the teams are actually working on these requirements, they deliver their deliverables include the status, the impediments, and the software code in itself, or whatever deliverables they are creating in order to meet this high-level requirements of the organization. And our area of interest is where the green arrow marks right in the middle, where the high-level vision of the organization gets translated into the smallest of the components of Agile delivery, which is a user story. And while that happens, it goes through various stages of transformation, from a high-level vision down to large solutions or capabilities, and from there down to the user stories which individual teams work on. So two key constructs that we looked at during this research are the Agile release trains and the capabilities. Agile release trains are a long-lived group of teams. So if an organization consists of thousands of employees, an Agile train may be Agile release train or ARTs, may be a smaller chunk of group which focuses on a particular capability and may consist of anywhere between 50 to 150 people. And capability is a first level of breakdown, if you will, of the largest requirements that the organization have, which are broken down into a fairly large piece of requirement, which is called the capability, which then further gets broken down into features and user stories for the teams to work on. So now from a multi-domain standpoint, so when this software development occurs, there are various domains involved, of course. The ARTs, which is the construct of interest, is the people domain because it consists of teams of people. And the capability is the component or the product domain because it defines what products needs to be built. And safe in itself is the process domain, which defines a set of processes for how the teams have to function and how the product would be built. And of course, in any large organization, when they're running at a high pace, it comes against a lot of challenges. For instance, the alignment of vision. When the requirements get translated from the highest level to the lowest level, there could always be a mismatch in alignment of vision because of how the communication happens and how the information gets translated from one end to the other. And timely identification of dependencies is always a challenge because teams tend to work on their requirements and tend to happen in silos if the communication channel is not well established. And this could lead to dependencies being identified late in the game and overall delays in the delivery of the product. And coordination issues as a part of having multiple teams is a natural occurrence. If the coordination setup or the communication channels are not clearly set up, it could result in various delays. So our research focus was on identifying how these coordination processes, which are evident through the multi-domain matrix methods, can help in early identification of these dependencies by visualizing the safe process in itself in a multi-domain metric format. So here's a multi-domain metrics in its truest form. So it combines, or it's a combination of various DSMs at the component people and activities level, which is the product, people, and process. And it looks at the interactions between these various aspects or domains to identify how they interact with each other and how well we can improve these processes. So the domain, the DMM or the domain mapping metrics is always the interaction between two different domains. And in this research, we have precisely used this particular aspect of MDM to identify how coordinations can be made better. And you can see a quote from Leffingwell, who is the authority figure when it comes to the scaled agile. He says there's always a struggle just to align multiple business departments with the same strategy, which is what we were talking about, the vision of the company. And even when the alignments across business department, even with that, there is yet another challenge to ensure the strategy is clearly communicated and delivered all the way down. So this is where it becomes important that we understand the dependencies and coordinate better in order to deliver the product. So what you can see here is a depiction of how Swisscom, our partners in this particular research, have organized their scaled agile processes within the organization. We looked at one of their lines of business, which is called DNA, which I'd be referring to in the latter part of this presentation. DNA is the data and analytics and AI group within Swisscom. It's a large solution group. It consists of 15 teams and their PI planning, which is another important ceremony in Scaled Agile, where the large groups come and plan for the next 2-3 months on how and what they are going to deliver, or what the key components are going to be their delivery. And capabilities are an important part of these PI planning sessions. So it's called the product increment planning or the program increment planning. And their releases are typically 2 months. So they try to deliver once in 2 months, whatever they have planned in a particular PI. And this planning session itself happens during 2 days where the entire team comes together and sits in a room and planning. I'm talking pre-pandemic, but that's how things used to happen. And the dependencies that require coordination, and this is something that we identified based on the conversations with our stakeholders, was that the capability dependencies and how these capabilities are delivered by large teams such as ARTs. So we looked at 3 main types of coordination requirements. The coordinations required at the capability level itself between multiple capabilities, at the ART level between multiple ARTs that deliver these capabilities, and the domain mapping between the capabilities and ARTs. So this is the translation of Swisscom's representation of Scaled Agile into the DSM based on what I had just discussed. So you can see here on the left-hand side, we have listed ART1. We expanded one particular ART to show how this can be scaled. So we looked at individual teams of that particular ART and mapped that to multiple different ARTs. So for instance, if there are 5 ARTs, we expanded first ART into a DSM and looked at that individual team level information or the features that they are delivering and how they have coordination requirements with other ARTs. And in the bottom half, you can see we looked at various capabilities, which is the next domain, and looked at how these teams are participating in these capabilities to deliver these capabilities. Between all these capabilities. So the brown and pink sections are the ones that show at a team level and at an ART level, the participation that is required to deliver each of these capabilities. So in the field study, our goal was to try and automate this rather than making it conversation driven and identifying dependencies. So we leveraged their project management tool called Jira, which holds this information. So Jira is a very popular project management tool that Scaled Agile teams or Agile teams generally use in order for their project management activities. And they store the information such as the user stories, features, who's working on it, etc. in Jira. So for our research, we leverage few of the key fields in order to identify these dependencies, such as the feature ID. So I just wanted to remind you that though we are looking at capabilities, features are the next level of breakdown of capabilities, and we used feature, which usually gets assigned to a team to work on, as our key construct in constructing this DSM. We looked at linked issues, labels, and few other key fields from Jira in order to identify what are the dependencies and which teams are working on it, so that we can build the DSM to represent that. We also conducted interviews with the product manager wherever there were gaps and to validate our understanding. And there were a few researches that were conducted in the past in partnership with Swisscom by MIT, which also played a role in providing input to this research. So this is the product, or this is the representation of one of the program increments. So we analyzed one of the program increments, and based on the information extracted from Jira, this is how we constructed this MDM. And the top DSM, if you will, contains the information. If you look at the left-hand side, you can see the team names. These are the actual team names which participated in that program increment from Swisscom. And we looked at their features. We looked at close to 200 features. And these were the features which were dependent with each other. And we looked at how these features are, how teams are delivering these features, teams who are delivering these features have dependencies with each other. For example, in the green DSM, you can see a cluster between, I don't know how legible these words are, but the teams mentioned in row number 4, 5, and 6, which is Firehose, storage and compute, and runtime and orchestration, the terms used by Swisscom. They have 4 features which form a cyclic dependency. So this means that these teams have to work really closely to deliver these features. So the information flow between them can happen back and forth, and they have to have specialized coordination mechanism in place in order to deliver these features. And you can see that there were a few other dependencies with external ARTs as well. So the interesting thing about ARTs is ART has a release train engineer who manages this, and every ART has its own schedule and release train engineers who manage that. So there requires an additional level of coordination between these ARTs. So we looked at various ARTs. So you can see in row 8, that is, 18, which is the last ART, ART MMA has a dependency on a lot of these teams. So it is imperative that all these teams work with the other ART and set up additional communication channels so that these features are coordinated well in order to deliver within that particular PI itself. And at the bottom, you can see that there are several capabilities, especially DNA116, which requires inputs from a lot of teams, or multiple teams have to work together in order to deliver this particular capability. And also, outside of our ART DL, which is the one that I have expanded here, the other ARTs should also be a part of DNA116. So this gives us a very different level of abstraction, if you will, to understand in order to deliver a particular capability, how many teams have to participate in it, and how many features have those dependencies in order to deliver that capability, which are dependent on multiple teams at the same time. And in the bottom right, you can see the capability DSM, which shows what is the level of dependency between various capabilities. And I want to remind you again that capabilities are a large piece of work, which takes multiple months to deliver. So it is important that teams understand the dependencies between capabilities at the beginning in order to deliver that. Because once they're halfway through or a lot way into the delivery, making changes can take a lot of time and effectively delay the releases very much. And one key important factor that the product manager had highlighted was this small red line, the part 3 of the DSM, which is the external dependencies. So external dependencies are with teams that are outside the purview of the organization, maybe an external vendor. So if there are, and they run in different cycles, not aligned with what the organization in question is running. So any delays can potentially, if the dependencies are identified very late in the game, it could push out a release by months together. So identifying these dependencies and representing them in this model was seen as a big benefit and a takeaway. So these are the main benefits which we validated by Swisscom by showing this DSM. So it creates a good improved focus groups based on the intra DL data lake is their ART. So based on how the coordination requirements are required within a particular ART and between ARTs could be identified using this visualization. And early identification and tracking of external dependencies is seen as a big benefit, so that, as I previously mentioned, delays of months could be avoided if we know these dependencies beforehand and they're represented adequately. And planning and prioritization of capabilities, that is the product, based on the interaction of the team or the dependencies with the team could be a potential benefit, because the Scrum Masters can then consider the availability of the team and staffing needs in accordance with what capacity is required to deliver a particular capability and plan accordingly well in advance. So that's the research in a nutshell. So the basic agenda of this research was to illustrate how an MDM can collect data across multiple domains, which namely ARTs and capabilities, forming the people and component domain respectively, in safe programs. And this visualization helps in identifying and tracking external dependencies and planning and prioritizing the capability or the large epics based on the team participation, and planning of distributed delivery of features based on the level of dependencies. So the teams can be aligned based on these dependencies, and demonstrate how data can be extracted from a project management tool as opposed to a conversation-driven approach, so which can in future be automated as well. So the creation of the DSM in itself or the MDM needn't be a time-consuming effort. However, this research has its own limitations because this was initially done in a very short span of time, and the amount of data that was collected was very limited because we could collect only for detailed feature level information only for one ART at a team level. But this can further be expanded to other ARTs and scaled, and we can go from there just from one organization or one line of business to the entire organization. So theoretically, there is no limit to how much this can be scaled. But since this has been tried only in a very small subset of data, it warrants future research to see how effective the scaling can be and how automated the DSM creation can be made once we actually try that. So these are some of the future works that we are proposing. So right now we have looked at people and the product domains. It can very well look in other domains of the organization. It can be we can look at the staffing organizations, the processes part of it, and the non-technical side of software delivery. And we can look at different levels of abstractions as well. So right now we are looking at the capabilities and ARTs. We can look at the lower level, which form, at the teams or individual team members, and we don't need to look at the capability level. We can look at the feature or even the story level to identify and represent that and draw insights from it. We can also look at how defect management can be better done by representing that as another domain or another DSM in itself. And we can look at various parameters. Right now we looked at features, but there are, a feature has various aspects to it, right? Such as business value or its priority capability. So we can represent the DSM not just based on the number of features they have dependency, but we can calibrate that based on the business value or priority and any other forms of information that characterizes a particular deliverable. So that concludes my presentation. Thank you all.
Great. Thank you, Nitin, for your presentation and for joining us today and for excellent research when you're a student with me at MIT. Okay, we have a third presentation in this session, but please, if you have questions for Nitin, continue to write them into the chat and we'll take them. So the third presentation comes to us from France, from Centrale Superlec. And I believe Miriam's given the presentation by video, although I see Miriam's also joined us. We're going to take the option to put you on live. We're going to run the video. What's the plan, Miriam? We're going to run the video. Is that correct?
Yeah.
Okay, great. Well, thank you for joining us. And here we go. Go ahead. Thank you.
I am currently preparing my PhD at Centrale Superlec under the supervision of Professor Frank Mar and Dr. Ludovic Alexandre Vidal. I'm here to present our research paper entitled Coordinating Synchronous and Interdependent Decisions in Complex Projects. This research is founded by the chair managing procurement risks in complex projects with the oil and gas company Total.
During my presentation, I will follow this outline. I will start by introducing the context, the objectives of my research work, and our research proposal. Then, I will detail proposals about problem structuring and modeling, and an example inspired by our oil and gas context will be presented to illustrate key aspects of these proposals. Finally, we will draw some conclusions and perspectives. Oil and gas development projects are technically complex as they may be carried out in difficult areas and multidimensional. This leads to highly independent decisions with multiple potential links of different intensity and nature. This implies difficulties in coordination and notably to ensure compatibility between decisions. Another major challenge in such projects is that they are uncertain and risky. In addition, this project involves multiple stakeholders and requires collaborative efforts and coordination from actors from different continents and domains. And this implies complex relationships between project stakeholders. In fact, these 4 issues identified from literature have been confirmed by a set of interviews carried out at the beginning of the thesis. The first industrial objective is to reduce inconsistencies and backtracking in the implementation phase, which can be critical and very costly for the project. The second one is to ensure a development concept that is compatible with the constraints of the future site and the expectation of the host country. Then, we have expressed these industrial objectives into 2 research objectives. The first one is to improve coordination between different decisions by ensuring consistency between their alternatives and by improving communication between the different actors implicated in these decisions. The second one is to propose decision-making strategies which are adapted to the context of multiple interdependent decisions in multiple possible contexts. As stated previously, a coherent set of decisions prior to the sanctioning of the project is important to the future success of this project. Our research question is thus how to choose between multiple alternatives for multiple decisions while ensuring their compatibility and performance. We introduce here the big picture of our research proposal. Complex industrial projects are characterized by tens to hundreds of decisions, and each of them having several alternatives. Since we deal with a multi-decision problem, our first proposal is thus to help choosing which decisions are included in the problem scope. So we propose 2 scope definition strategies, respectively called the decision package or synchronous strategy and the lonely decision or asynchronous strategy. These 2 strategies won't be detailed in this presentation. However, it is important to note that both strategies end up with an analysis of several interdependent decisions. This means that whatever the strategy, the methodology for proposing recommendation will be the same. Classically, we consider only 2 matrices: the decision cross-decision alternatives, DMM, for identifying and structuring possible alternatives for each decision, and the decision alternatives cross-objectives, DMM, for identifying performance of decision alternatives. An MCDA method is often used to make a choice considering performance only. Here we also consider the interdependencies between the decisions, modeled through the DSM D cross D, decision cross decisions. So, when we combine these 2 matrices, we get interaction between the alternatives modeled here by the matrix DA cross DA. This matrix leads us to the possibility of considering an additional factor, which is the compatibility in the global evaluation. Different resolution strategies are possible. The first strategy considers the performance, then the compatibility with 2 sequence filters. The second one simultaneously considers both parameters, while the third one sequentially considers the compatibility, then the performance. We eliminate the first strategy because it may generate deadlocks, and the 2 remaining strategies correspond to quite established methodology, respectively the quality function deployment, the QFD, and the morphological approach. Finally, we need to select and use a multi-criteria decision approach, and our originality being to consider compatibility and performance. This aspect is not detailed here, since it corresponds to the current phase of the research. So, the focus of this presentation will only be on the second part of the process, the structuring and modeling of the multi-decision problem. The technical basis of this part will be visually illustrated with an example of 6 decisions from the OI context. We suppose here that we have chosen the decision package strategy, but this choice is not significant here. Indeed, whether the scope definition strategy, the methodology for proposing recommendations will be always the same. In this part, 4 matrices are used to model the decisions, their alternatives, and their objectives. We have first a decisions cross-decisions DSM, second a decisions cross-decision alternative DMM, third we have a decisions alternatives cross-decision alternative DSM, and finally a decision alternatives cross-project objectives DMM. The first matrix to be constructed is the decision cross-decision matrix. This matrix is important, since to successfully manage decisions in a complex project, their interdependence need to be analyzed and integrated into the decision-making process. In fact, Decision Structure Matrix, DSM, has proven to be a useful tool for modeling complex projects and their objects. And among these objects, we find decisions. We can refer here, for example, to Compania, who proposed to model the global decision environment and not only the decisions themselves using DSM. For example, here for our example, there is no relationship between the contracting decision strategy and the well-architectured decision. The second matrix to be constructed is the decision cross-decision alternatives DMM. This matrix corresponds to the first one used in the morphological approach. It is constructed to generate the possible scenarios involved in the multidimensional problems. In this approach, it is also called a morphological matrix. So, we have as input the columns which present the criteria of the morphological analysis, which in our case correspond to the decisions to be taken, and the rows which present the conditions for each criterion, which in our case correspond to the alternatives for each decision. So finally, to identify a possible scenario, we have to select a single value for each alternative. And in our case, we have a morphological matrix with 3,840 possible scenarios. The third matrix is the decision alternatives, cross-decision alternatives, DSM. Its purpose is to evaluate for each pair of decision alternatives whether or to what extent that pair can represent a compatible relationship. For the QFD approach, it corresponds to its upper matrix, also called the roof of the house. As for the morphological analysis, it corresponds to the second matrix that is constructed to converge on a short list of the most plausible scenarios. So for this matrix, you have as input alternatives of decisions and as output scenarios evaluated in terms of compatibility. The last matrix is decision alternatives cross-project objectives DMM. It corresponds to the lower part of the QFD approach. In such a matrix, decision alternatives are evaluated against well-defined objectives, and each of them is characterized by a well-defined weight. The aim of this matrix is to evaluate the performance of each possible scenarios. Based on the different matrices developed, different resolution strategies can be applied to select which scenarios will be investigated with the MCDA method. We have already indicated that the first strategy is eliminated. The second one consists in choosing scenarios considering simultaneously the compatibility and performance parameters. This strategy corresponds to the QFD approach. It is structured by three main parts. The upper part allows to study the compatibilities between the decision alternatives, while the lower part allows to evaluate them with respect to the objectives. And the decisional part allows to evaluate the possible solutions by selecting and assembling one alternative per decision. This allows finally to build scenarios based on several interdependent alternatives while considering their performance and their compatibility. For this approach, the MCDA method should be applied to select a scenario considering the performance and compatibility of its component. This MCDA method should be selected by considering the higher degree of heterogeneity between criteria. The third resolution strategy consists in choosing scenario considering the compatibility parameter and then the performance parameter. This strategy corresponds to the morphological analysis, since its first phase is used to perform a first filtering by identifying the plausible scenarios with a DA cross DA matrix, and its second phase performs a second filtering to deduce the best scenarios among plausible scenarios in terms of performance. This means that scenarios are built in two stages, and it is up to industrial decision maker to choose which strategy is most suitable for them. We pass now to present our main contributions. The first contribution concerns the scope definition of the decision problem. In fact, we have here the possibility to parameterize the output of the decision problem and to choose between deciding one decision among n or deciding all decisions at once. However, whatever the scope of the problem, it is important to note that the methodology for proposing recommendations will always be the same. This contribution was not detailed here due to time constraints. The second contribution concern the modeling and structuring part of the problem. It consists in offering the choice in the structuration of the problem whether to select the scenarios from 2 criteria taken simultaneously or 2 criteria taken sequentially. So, to choose finally between making a 1-step or a 2-step choice. And finally, the third contribution concerns the MCDA part. For all strategies, a MCDA method must be applied. For the QFD approach, the MCDA should be applied to select a scenario considering the performance and compatibility of its components. While for the morphological analysis, it must be applied to select a scenario considering only the performance parameter, since a set of plausible scenarios has already been identified. There are a lot of multi-criteria decision methodology in the literature that allow to extract choices from data resulting from our phase. However, for the moment, we have not addressed the question of the methodological choice of the MCDA method, and this is one of the next steps of this research.
Thank you for your attention, and I hope you enjoyed the presentation.